Okay, now, so you're now going to fill in the chart that is down at the bottom of the page. Now I'm having to modify it for you so that it's not as difficult as what it looks like in the lab. So you should have measured the distance between the two lenses that you used for your telescope. Okay, and then if you go back up into the concept introduction, there is going to be a formula that says the optimum length of a telescope should be something plus something. So go back up into the concept introduction and you're going to find that equation for the distance between the two lenses in a optimum refracting telescope. And then what you're going to do is compare that distance, so that would be your calculated distance between the two lenses, to the measured distance between the two lenses. And it should be pretty good when you do that. Now I want you to try one more thing. So I would like for you to, I originally said to do this. Okay, now do this. Okay, so swap your two lenses and see what happens. Okay, notice what happens to the image of the very far away object when you do that. So what you're going to find is that if you've got two different focal lengths, when you do it one way, you're going to get a good telescope. When you do it the other way, you're going to get a bad telescope. So it's going to be like taking a pair of binoculars and looking through the binoculars the way you're supposed to, and then taking the binoculars and flipping them around and looking into it backwards. That's essentially what you're doing by taking your two lenses and flipping them around. So one way should make a good telescope, the other way should not make such a good telescope. Now another thing I'd like for you to try to do is to get the magnification of your telescope. So to do this, you're going to use whichever combination of lenses gave you the good telescope. Find something on the wall. Could be a clock, it could be a lamp, could be words on a book or something like that, and estimate how big does it appear to be in the telescope. Is it 3 times larger than what it normally would be? Or is it 5 times? Or is it 2 times? So that's the magnification. How much larger does the image in your telescope look compared to how does it really look without the telescope? Okay, then the next thing that you're going to do is, if you'll go up into the concept introduction, there is a second formula that allows you to calculate the magnification of a telescope. So I want you to calculate the magnification and then compare it to what you saw when you looked through your telescope. And again, it should be fairly accurate. Okay, so that is the lab. Okay, so you're going to make a telescope. You're going to measure the focal length of each of your lenses. Then you're going to measure the distance between the lenses when you make your telescope. And you are going to observe something and estimate the magnification of your telescope. Then you're going to calculate with a formula the distance between your lenses and then compare it to what you measured it to be, and then you're going to calculate the magnification and compare that to what you looked when you looked through it. What did you see? So I want you to do all of that and write it up in the lab somewhere for me. Okay, then on the post-lab questions, you can do them all. Okay, question number 6 says, which type of mirror is used in the backs of reflecting telescopes? So if you don't know the answer to that, go to Google, find it, and then answer that question. What type of telescope, a reflecting telescope or a refracting telescope, is used by astronomers today? So what kinds of telescopes what are modern telescopes based on? Is it based on the principle of reflection or refraction? Look it up if you don't know. And then question number 8. A certain telescope uses an eyepiece with a certain focal length. If the eyepiece is changed to one that had a larger focal length, what would happen to the magnification of the telescope? So you're going to use the formula for magnification of a telescope in order to answer that question. Then question number 9. A telescope has an eyepiece that has a focal length of 10 centimeters and an objective that has a focal length of 20 centimeters. What is the magnification of the telescope? So you should be able to do that. You're going to use that formula to calculate that magnification. And then on question number 10, if a telescope in question 9 were to look at an object which was 1 inch tall, so the real height of the object is 1 inch tall, how tall would it appear to be in the telescope? Okay, so see if you can answer that question. So that's the lab on reflection and refraction and making a telescope. So answer all those questions, email it to me, and then I will see you back in class.